Lesson number 4 looks at calculating the measure of an angle in a right triangle. So in the last lesson, we calculated side measurements. So given an angle and a side, can you calculate the other sides? In lesson number 2, we learned how to determine the measure of an angle given the trig ratio by reversing or inversing the process. So for example, if I have that sine x equals 0.45, to figure out angle x, I reverse the process by using sine inverse. So I go second sine, and I get this -1 exponent, which means sine inverse, 0.45, enter, and I get 26.7, or to the nearest degree, 27 degrees. So take a moment and do the same thing for the cos y equals 0.1624 and tan z equals 5 2/10. So for cos, you should have gotten 81 degrees, and angle z should be 79 degrees. So again, to calculate the measure of the angle, we need to know which trig function to use. So from the given angle, we need to label these two sides with the words that we know. Things like hypotenuse and adjacent. I know that this is the adjacent side because it's next to it. I know this is the hypotenuse because it's the longest side. The trig function that connects adjacent and hypotenuse is cos. So listen, this is hypotenuse. The trig ratio, which involves the adjacent side and the hypotenuse, is the cosine ratio. So I have cos A equals 16/34. So then angle A would equal cos inverse of 16 divided by 34. So do that calculation for me and write down what you get for your angle. Because I get angle 62 degrees. So with class example number 1, I'm going to do one of the triangles, then I want you to press pause and do the other two and watch the other two. So if I look at class example A, in relation to this unknown angle that I have to solve for, I call this the opposite side and this the hypotenuse. So the trig function that relates opposite and hypotenuse is sine. So sine of angle A equals 4/6. So then angle A would equal sine inverse 4 divided by 6, which when I put that calculation into my calculator, and I can put it in as 4 divided by 6, sine inverse 4 divided by 6, I get 41.8, which becomes 42 degrees. So press pause now, and then when you're ready, press play to look at B, and then if you want, you can press pause and then look at C after. So if we look at B, in relation to this angle, this is my adjacent side, and this is my hypotenuse, longest side opposite the 90 degree. So the trig ratio that compares adjacent and hypotenuse is cos. So I've got cos of angle B is 10/19. So then angle B would be cos inverse 10 divided by 19, which equals 58 degrees. So again, try doing class example 1C. Now 1C is a little bit unique because I'm given all three sides. I'm given the hypotenuse, I'm given the adjacent side, and I'm given the opposite side. Which means realistically I could use any one of those three trig ratios and I would be able to solve it provided I used the correct two sides. So because we haven't used tan yet, I will use tan of angle C equals the opposite side over the adjacent, 21/20. So then angle C would be tan inverse 21 divided by 20, which if I put that into my calculator, tan inverse 21 divided by 20, I get 46.3, which becomes 46 degrees. So I want you to take about, it shouldn't take you more than maybe about 5 minutes, maybe up to 10, but shouldn't be more than 10. And I want you to do question 1 and 4. So the next part of this lesson looks at angle of elevation and angle of depression, which again we did in the last chapter. If I have angle of elevation, to elevate means to look up. So elevation means I'm looking straight ahead and I look up. Well, what angle did my eyes make from being straight to looking up? That's my angle of elevation. Angle of depression is looking down. So I'm looking straight ahead and now I look down at the floor. What angle did I create? That becomes my angle of depression. So my line of sight is looking from one point to the other, and then the horizontal line is wherever I'm starting from. So if my horizontal line is starting from the ship, and I'm looking up at the helicopter, that becomes my angle of elevation. However, if I'm at the helicopter and I'm looking down at the boat, that becomes my angle of depression. Now, something to remember from the last class or last course, if I have two horizontal lines, they are parallel to each other. This line of sight becomes a transversal. And if you remember, if I have two parallel lines and a transversal, the alternate interior angles are equal to each other. So this angle of depression here becomes the same as the angle of elevation here. And that can help us when we're drawing out our triangles. Angles of elevation and depression are determined from the horizontal, not the vertical. So, class example number 2. A tree is 5.1 meters tall. 5.1 meters tall. The shadow it casts is 7.5 meters long. Calculate the angle of elevation of the sun to the nearest tenth of a degree. I make this into a triangle. The angle of elevation of the sun, angle of elevation. This is the angle I'm asked to calculate right here. Greek letter theta is what we use for angles if we don't have any letters to put in place. So if I'm calculating this out, tan theta equals the opposite over the adjacent. So then angle theta would be the tan inverse and if I do that calculation, I get to the nearest tenth of a degree, 34.2 degrees. So angle of elevation is 34.2 degrees. So let's move to the next example. A boat is 130 meters from the base of a cliff, and the cliff is 80 meters high. So we have a cliff. So cliff. The boat, so here's my water, here's my boat. The boat is 130 meters away. The cliff is 80 meters high. Mark the angle of depression of the boat from the top of the cliff. So there's my triangle. The one assumption I'm going to make is that the cliff and the water meet at a 90-degree angle. Angle of depression would be right here. This would be my angle of depression. And the question is, determine to the nearest degree the angle of depression of the boat from the top of the cliff. Well, I can do this one of two ways. First way, I can make another right triangle. So this measurement here would be 80, this measurement here would be 130, and I would have a triangle that goes like this. And I would be finding this angle. Or I could recognize parallel lines, transversal, alternate interior. That's also going to be angle theta. But when I do this in either form, if I calculate from this triangle, I have an opposite and an adjacent, because this is my 90 degree. This is tan. Tan theta equals opposite over adjacent. Right here, tan opposite over adjacent, it's the same calculation. So then angle theta would be tan inverse 80 divided by 130, which gives me, to the nearest whole degree, 32. So the angle of depression is 32 degrees. Okay. The last question that we have deals with an isosceles triangle. What to remember with an isosceles triangle is two side lengths are the same. So KL is 20, LM is 20, and KM is 30. Okay? Can I use SOHCAHTOA to determine the measure of angle KLM? Yes or no? If your answer is no, why? I can't use this because it is not a right triangle. SOHCAHTOA only works for right triangles. Can I make this a right triangle? Well, I can. I can drop a line from L to this point. When I do that, because it's an isosceles triangle, I will create this triangle here, which is 20. We're going to let's call this point P. So I have K, L, P. The distance from K to P is 15. I know it's 15 because if I drop a line from an isosceles triangle from this angle here, it's going to create a 90 degree. These two angles here are the same, so I get two identical triangles. If I find this angle, I can double it to get the full one. So I want to find angle L. Opposite side, hypotenuse. Which trig function do I use? I use sine. Sine of angle, let's call this one, we'll call it X, just so that we don't get confused. Sine of angle X, because I don't want to use L, is 15 over 20. So then angle X would be the sine inverse, 15 divided by 20, and I get 48.59 degrees. So then angle KLM would be 2 times that amount. So to the nearest degree, that would become 97 degrees. So to add from the questions from before, I would like you to do question number 6, 9, 10, 11, 12, 13,